Hello everyone, welcome to my channel. Let's learn computer science. Hello everyone. Have you ever wondered how a greenhouse automatically waters plants when the soil becomes dry? Or maybe how a car can automatically apply brakes when it senses an obstacle ahead? Or maybe your room's air conditioner, how it knows when to stop cooling? Well, all these systems are examples of monitoring and control systems. In today's session, we'll understand what monitoring and control systems are, how sensors they collect data, different types of sensors and their applications, what actuators do, the difference between monitoring and control systems, importance of feedback, and finally, we'll have a look at some exam style questions as well. So let's get started. First of all, let's understand what are monitoring and control systems. Monitoring and control systems are systems that use sensors and microprocessors to gather data, and in some cases, automatically responds to it. You'll find these systems everywhere around you: greenhouses, hospitals, manufacturing industries, smart homes, vehicles, and IoT devices. In fact, you probably interact with several monitoring and control systems every day without even realizing it. So let's understand the process. Let's see what actually happens inside one of these systems. Imagine you're driving a car. The system first uses a sensor to collect information from the environment. And this information is converted into a form that computer can understand. The processor then compares the data with some preset standard values which are saved. Now, two things can happen. One, it can be part of a monitoring system, and two, it can be part of control system. If the system simply displays the information for a person to read, for example, a speedometer showing the speed of a car, then the system is only monitoring. It's not taking any action. And in case the system may actually automatically take some action, for example, an air conditioner turning itself on or off depending upon room temperature, then that means it's a controlling system. It's controlling something, right? So if you look at this flow chart, you'll see that first thing is that sensors, they are sending signals to the microprocessor or computer. So sensors, they are continuously gathering data from the environment and they are continuously sending it to the microprocessor. Now, these signals are converted to digital if required using an analog to digital converter, which is ADC. And the microprocessor or computer analyzes the data received by checking it against some stored standard values. After this, it can either go into a monitoring system or it can be a controlling system. Now, if new data is outside the acceptable range and a warning message is sent to the screen or an alarm is activated only, then it is a monitoring system. And after that, the microprocessor or computer has no effect on what is being monitored. It is simply watching the process. However, in case it is a control system, then if the new data is outside the acceptable range, the microprocessor or computer sends signals to control valves, motors, and so on. And here comes the task of actuator. We will cover in detail what actuators are in this video. However, as of now, actuators, they take some action, you know. So the output from the system affects the next set of inputs from the sensors, and this continues, this loop continues. There is a feedback. So whatever it happens, then again it is sent back to the system and the readings are changed and accordingly the action is changed. So this is a loop, this is a feedback loop, which is a continuous thing. Now let's talk about the most important part of these systems: sensors. A sensor is an input device that measures a physical quantity. For example, temperature, sound, light, pressure, humidity. think about your body for a moment. Your eyes, they detect light. Your ears, they detect sound. Your skin detects temperature. In a way, our sense organs, they act like sensors, right? So computers also need sensors to understand what's happening around them in order to get some data from the surroundings, right? Real world data is all analog, right? Continuous and constantly changing. And you know that computers, they work with digital data. So we need a system that, converts these analog data into digital and digital into analog. So ADC, analog to digital converter, it converts analog signals from sensors into digital signals that the computer can process. And DAC, digital to analog converter, it converts digital signals back into analog form. Now let's talk about common types of sensors and their applications. First of all, temperature sensor. Temperature sensors measure heat. We can use them in greenhouses, chemical processes, air conditioning systems. I have mentioned whether it's a control system or a monitoring system. Please have a look at your screen and take notes if required, because this is very, very important from exam perspective. Next comes humidity or moisture sensor. These sensors, they measure moisture levels, and application areas are smart irrigation systems, greenhouse, industrial environment, etc. Light sensors, these detect light intensity, and these can be found in automatic street lights, security lighting, smartphone brightness adjustment, etc. Next comes infrared or motion sensor. They detect movement, and their application areas are automatic doors, security systems, burglar alarm systems. Then we have pressure sensor that measures force or pressure, and their application areas are air pressure monitoring, vehicle systems, industrial equipment, etc. Then we have sound or acoustic sensors. They detect sound. Their examples are glass breaking alarms, security systems, industrial monitoring, etc. Then we have gas sensor. Gas sensors measure gas concentration. We can use them in pollution monitoring systems, greenhouses, industrial safety systems, etc. Then we have pH sensor. They measure acidity or alkalinity. They are used in water quality testing, soil analysis, agriculture, etc. We also have magnetic field sensors. They detect magnetic fields, and their application areas are electronic compass, vehicle braking system, etc. Now let's also talk about what are actuators. When we talk about controlling system, we say that they take action. Now how the actions are taken? Who performs the action? That's where actuators come in. An actuator is an output device that performs an action based on control signals. Now you can think of it this way. A sensor is like the eyes or ears of the system. An actuator is like hands or legs. They actually do something, some action they take. For example, a motor turning a fan, opening or closing a valve, moving a robotic arm. So all these are examples of actuators. Now let's have a look at the difference between monitoring and controlling systems. Now, students, they often confuse these two concepts. Let's make it very simple. Monitoring system is basically where data is only observed or information is collected. We just report results, but these systems, they do not automatically respond. For example, a thermometer in a laboratory, it tells you the temperature, but you decide what to do next. But in a control system, they collect data, they make decisions, and they take actions automatically without human intervention. For example, an air conditioner. If the room becomes too warm, it automatically turns on. No human intervention is needed, right? Now, in these systems, feedback is very, very important. That is the most important concepts in control systems. Feedback is basically the information which is sent back to the system after an action has been performed. And why is it important? Because it allows the system to know whether its action worked or not. And what to do next is based on that feedback. Okay, now let's talk about a real life example of thermostat controlled air conditioner. Imagine you set your AC to 24 degrees Celsius. The temperature sensor measures the room temperature, and if the room becomes warmer than 24 degrees Celsius, the AC turns on. As the room cools down, the sensor continues measuring temperature, and this new reading is sent back to the system. This is feedback. Okay, when the temperature reaches the desired value, the AC switches off, and this process repeats continuously. This is called a feedback loop. So without feedback, the system wouldn't know whether the room has reached the required temperature or not. Okay, so that is why feedback is important. Now let's have a look at some past paper questions. Let's apply what we have learned. So this is a question from October-November 2024 about a car that has automatic braking system. A sensor measures the distance to an object ahead. As the car approaches the object, the distance changes, and the system uses this information to decide how strongly the brakes should be applied. What they're asking is, why is this a control system? Now, we have already covered what is a control system, right? Now, in this scenario, this is a control system because the sensor provides feedback, the system processes the data, and system automatically makes decisions, and the brakes are applied without human intervention. That's exactly what a control system does, right? So this is the answer key. Have a look. Let's have a look at one more question. Explain the importance of feedback in a control system. So that's what we have just discussed. Feedback ensures the system operates according to the required criteria. It allows the output of the system to influence future inputs. This enables conditions to be adjusted automatically and continuously. So this is the answer key. Have a look. You can make note of it. Let's have a look at one more question. Identify one sensor that could be used in a car alarm system and justify your choice. You can write about any sensor that can be used in this situation and write your justification. So you can talk about sound sensor, infrared sensor, pressure sensor, and then just write one point about that. This is the marking scheme. Have a look. They have written about sound sensor, infrared sensor, pressure sensor. One mark is for identification of the suitable sensor and one mark is for corresponding justification. So that's all for today. We have covered sensors and their role in monitoring and control systems. In next video, we'll discuss about logic gates and logic circuits, truth tables, etc. Till then, take care. Bye-bye.